Okay, so there is a particular step that's, there are a few steps that we need to follow. And if we do these steps, there is absolutely no way that you can go wrong. So initially, when you start out doing these steps, it will take some time. In fact, it will take quite a bit of time for you to get used to it. But once you practice enough number of questions, even without using this table method, you will automatically be able to do it in your head. Okay. So you won't even need to draw a table and all that. So let's look at the table method first. So basically, if the number of each atom on either side is the same, you're good and the equation is balanced. So what you're first going to do, so if you look at the left hand side of this equation over here, let me look at mercuric oxide. Okay, mercuric oxide, mercury on the left hand side, I have one atom. On the right hand side of mercury, I have one atom as well. Okay, so both sides I have one atom of mercury, so I don't have to worry about that. Everything is fine. So let's go back to our table, or sorry, the method. It says if the number of each atom on either side is not the same, you need to use big numbers in front of each element or compound or to even them out. So if the number of each atom on either side is not the same, so if it is not the same, then you need to use big numbers. What is the meaning of big numbers? No. So big numbers means the numbers that you put on the left hand side of the compound or the molecule. Okay. For example, if I put a number on the left hand side over here, okay, then this will be a big number. Okay. Any number that I put on the left hand side, if I put it over here also, that is also a big number. Here, that is also a big number. So towards the left hand side of any compound or molecule, I put a big number. I'm sorry, a number that is called a big number. Okay, and what does a big number do? So for example, if I put 2 over here, what does that do? It multiplies everything on the right hand side of the of molecules of mercury is 1. Number of atoms. Number of atom of mercury is 1. Number of atoms of oxygen is also 1. Now I have put the big number 2 on the left hand side. So 2 will multiply with 1 and 1. And basically I'll end up getting 2 atoms of mercury and 2 atoms of oxygen. Is that clear to everyone? Okay, so big numbers are numbers that you put to the left hand side of a compound or a molecule. Now, these big numbers, what they do is they multiply all the atoms to the right hand side of that particular compound or molecule. Okay. So the next step is every time you add a big number, you multiply the whole compound by that number. And so you adjust the numbers in the table accordingly. Then you repeat until you have the same number of every atom on the left hand side and on the right hand side. Okay, after that point, it's a little complicated to understand. So let's just move on and start solving so that we understand what this table tally method is actually saying. Okay, so all right, so this is an example. All right, so here I have calcium nitrate. All right, and reacting with sodium to give me NaNO3 plus calcium. Okay, so this particular equation, I'm just going to write down all the elements that are involved in this equation. So I have calcium. I'm going to first form a table. In the table, the first column will be element, the second column will be LHS, and the third column will be RHS. Okay, LHS and then RHS. Then I'm going to list down all the elements that I have within that equation. So in that equation, I have calcium, nitrogen, oxygen, and sodium. So I'm going to write down all the elements. Then I'm going to put the number of atoms on the left hand side of the equation. So on the left hand side, I have 1 calcium. So I'm just going to write 1. Nitrogen, I have 2, because if I look over here, with nitrogen is within this bracket, and outside the bracket I have the number 2. That means anything that is inside the bracket is being multiplied with 2. So nitrogen inside the bracket has just 1. Now this 1 atom multiplied with 2, which is outside the bracket, will give me 2 atoms of nitrogen. So that is why I am writing 2 over here. Similarly, with oxygen, inside the bracket, the oxygen has 3 atoms. Outside the bracket, I have the number 2. So 3 multiplied with 2, I have 6 atoms of oxygen. And sodium, I just have 1, so I'm just going to write 1. Similarly, on the right hand side, I have 1 sodium, so I'll just write 1. I have 3 oxygen, so I'll write 3. I have 1 nitrogen, so I'll write 1. And 1 calcium, so I'll just write 1. Now, if we notice that the numbers that are written in red, okay, so like calcium 1 and 1, it's balanced on both sides, I don't have to worry. Sodium 1 and 1, balanced on both sides, I don't have to worry. But nitrogen is 2 on the left hand side, but on the right hand side it's just 1. Oxygen is 6 on the left hand side, and then on the right hand side it is 3. What I'm going to do is first I'll start off with nitrogen. Okay, so in order for me to balance nitrogen, I somehow need to bring 2 nitrogens on the right hand side. So what do? I'll put a big number on the right hand side in front of the compound which has nitrogen. Okay, so the compound which has nitrogen is NaNO3. So in front of NaNO3, I'll put 2. If I put 2, what happens to this table? In this table, calcium will remain the same. Nothing changes on the left hand side. On the right hand side, calcium remains the same. Nitrogen now becomes 2. Oxygen becomes 6 because I've put 2 over here, and this 2 multiplies with every single element in this particular compound. So 2 times sodium, 2 times nitrogen, 2 times oxygen. So nitrogen becomes 2 times, oxygen becomes 6 times, and sodium becomes 2 times. Now what has happened is my nitrogen is balanced, oxygen is balanced, but sodium is not balanced. So what do? I go back to the left hand side because left hand side is less than the right hand side. So I have to add a big number to the left hand side. So I'll go to the left hand side. I'll see, okay, sodium has 1 on the left hand side, and on the right hand side it has 2. So I'll put a big number on the left hand side. I'll put the number 2 on the left hand side. And now right hand side remains the same, 1262, but the left hand side will change. So this will become 1, 2, 6, and sodium, in front of sodium I've put the big number, so this will become 2. And now my equation is balanced. Did everybody understand till here?